So if you missed this lesson, you can go back and watch it. What we talked about yesterday was the graph of a normal sine function and a normal cosine function. Then we also added in that amplitude. Okay, so after adding in the amplitude, I have one more thing I want to show you before I set you free to go ahead and do some homework assignments. I'm going to try to keep it down to just 2 shorter examples today to give you lots of time to kind of try that homework. So the second thing that we add in is a b value. So we've currently said we either have a sine of x or a cosine of x. So the one variable I'm going to add in now is a b value, and that b comes directly after the trig function before that x variable. So we're going to see this come in a sine b of x, a cosine b of x. So we already talked about this a value. That a value was the amplitude. So as a reminder, that either, like if say that b or the a value is 2, now we go up 2, down 2. Say the a value is 1/2, we only go up to 1/2 and down to 1/2. So it either shrinks or stretches vertically with that one. This b value actually changes our period length. So think about a normal cosine function, or let's do a sine function instead. A normal sine function starts at 0, it goes up, it comes back down, and it ends at 2 pi. Here is pi, 3 pi over 2, pi over 2. That's one full period of a normal sine curve. So what this b value does is it either shrinks us vertically or horizontally, or expands us or stretches us vertically. So if this b value is between 0 and 1, okay, a b value between 0 and 1, this is actually, it's kind of the opposite effect. It's actually going to horizontally stretch this value in this function. If b is greater than 1, it's going to do the opposite effect. Okay, so if it's not a fraction less than 1, it's going to actually horizontally shrink the graph of this function. Okay, so this is one that I think a lot of people have the hardest time with. Adding it in without the other effects can be kind of easy, but once we start adding in the other effects, this is the one that makes it the hardest. So showing you an example is probably going to be the easiest way to do this. When we find this b value, we have to do one thing. The b value essentially finds us a new period. But we have to know, like, well, how do we even do that? When we get that b value, how does that magically make a new period for us? So the way that we find this new period is we take 2 pi. Why 2 pi? Because 2 pi was the period of an original cosine or sine function. Okay, so we take that original function and we actually divide it by our b value. So finding that b value, the original period of the function, and divide it by our b. So let's start out by graphing let's do y equals 2, is that what I want to do? Yeah, let's do 2 sine x over 2. Y equals 2 sine x over 2. When I break some of these problems up for you, I won't have them this condensed, but when you see a problem like this in the book, they will have it this condensed. Hey, Morgan. All right, So the way that we have to break this up to find our b value is we have to think about Well, what is x over 2 representing? If I want to find a b value separate from that x value, how did I ever get x over 2? So we can pull out the fraction from this. That fraction is actually 1/2. Okay, so we can change this function from being y equals 2 sine x over 2 to 2 sine 1/2 times x. Again, we pulled out this fraction. When we have 1 sine or 1x over 2, that technically is pulling out the fraction of 1/2 multiplied by x. Does this chunk right here, like going from this step to this step, is that good? Do you have questions on that? Okay, awesome. So now we can go ahead and say, what's my a value? A value is what comes first, right? So a value is 2. Then we say, well, let's identify our b value. What's our b value here? That is what's directly in front of the x. So our b value is 1/2. I do have to take this a step further though and say, well, what does this do to my period? What kind of new function will I have, a new period will I have because of a b value of 1/2? So let's find our new period. That would be taking 2 pi over b, right? That's how we find our new period. So let's take 2 pi and divide it by our b value of 1/2. So when we divide by a fraction, it's the same thing as multiplying by its reciprocal. So we, instead of having 2 pi divided by 1/2, we'll have 2 pi times the reciprocal of my denominator, which would be 2 over 1. So 2 pi times 2 over 1 is, see this low? Yeah, you can. Is 4 pi, right? Because we multiply straight across. It's like putting a 1 under 2 pi. 2 pi times 2 is 4 pi. 1 times 1 is 1. Okay, so we get a new period of 4 pi. So let's start trying to graph this out. Let's make our axis. The first thing we know is that this axis is going to have to go up and down to the value of 2, right? Up to 2 and down to 2. So -2, +2. Again, why? Our amplitude is 2, so that says that this function will rise to 2 and will go all the way down to -2. Now we have to deal with the period length though. Okay, so what happens is because we had a b value that was between 0 and 1, this is actually going to stretch it out. A smaller b value makes this function even longer than it usually is. So our normal period is 2 pi, our new period is 4 pi. When we think about a sine function, we have 1, 2, 3, 4, 5 points to it, but oh, you can't see my last mark. We have 5 total points to it, but we end up breaking this up into 1, 2, 3, 4 different sections. Okay, so 5 points, but we break it up into 4 equal sections. So if my period length needs to be a full 4 pi, I need to divide 4 pi up into 4 equal sections. Okay, so I started us off with a little bit of an easier one. If we want to divide 4 pi into 4 equal sections, each of those sections will be pi length. Okay, so when you go to create these new division lines, you take your new period, divide it by 4 to get what each equal section should be. Now it's my job to go label this axis. I start out with pi because that's my first, like between 0 and this one should be a full pi length. So be 0 plus pi equals pi. Now I add on a second pi to get 2 pi. Add on another pi to get 3 pi, one more to get 4 pi. We can go in the negative direction, negative pi, negative 2 pi, negative 3 pi, and negative 4 pi. Okay, are you guys still with me? Questions? You can type them in the chat if you don't want to say them out loud. Okay. Now that I've found all of my division lines and I've found how high and how low this function should go, it follows a normal sine curve. So a normal sine curve starts in the origin, right? And then its first point goes up. Its next point comes down to the axis. Its next point after that goes down all the way to the bottom and then back up. And it follows that same method this way. Right, so if I draw this curve all the way through, it'll end up looking like that. Any questions whatsoever so far? Like, this is not the easiest thing ever. This is not easy at all, actually. It's very difficult. So if you have questions, it's not a surprise.
For the period, like even if the period wasn't 4 pi, like say it was like 2 pi, would you still divide it by 4 to get the division lines?
Yeah, that's an absolutely great question. Every single time we have to divide it by 4. No matter what that period length is, divide it up by 4, because we always will have those 4 equal sections. That's a great question.
Okay.
All right, I'm going to show you guys one more. If you are like, this is so stupid, I got this, stop talking to me, the homework is already posted. So if you want to go ahead and get started on that, you are more than welcome to. The homework is posted. It's on both like the assignment page on Google Classroom. So I made an assignment. I posted the homework there. I also posted it in the slides for this week. So you have 2 different places you can go look for it. Once we're done with this entire section, so this next example, I'll post it in the chat too. But I want to show one more example for anyone that wants to listen to it. But if you got it, I'm not going to stop you from starting your homework. The next one I'm going to do is going to have a whole number b value. Okay, so we had a fractional b value, and now I want to try a whole number b value with you. And we'll do a cosine function this time. So I want us to graph y equals, let's do 1/2 cosine 2x. That works. 1/2 cosine 2x. So in this one, again, identify my A, my B, find my new period. First things I'm going to do every single time. Whenever we start adding in new information, start identifying each one of those pieces every single time. A value, super quick and easy. First thing in there, 1/2. B value comes directly in front of the X value, so that is 2. So to find my period, no matter what, it's always 2 pi divided by B. So we're going to have 2 pi divided by 2, because that 2 value is my B. So this one starts working out. So that 2's cancel. My new period length is just simply pi. Okay, so I have a new period length of pi. I have to take this pi and say, well, that's great. I have a period length, but now I need to find my 4 equal sections. Okay, so I know I'm only going up to 1/2. That was a really bad 1/2. I'm only going up to 1/2 and down to negative 1/2. But what are my division lines going to be? And I try to draw these to scale as best as possible. Sometimes it gets tough because you don't know what your division lines are going to be and how long each one of those are until you start figuring this out. As always, every single time, take your new period and divide it by 4. That will be the length of each section. Okay, so this isn't to say that you label it all pi over 4, pi over 4, pi over 4. this is the length of each one of these 4 small sections. So this one equals pi over 4, this one equals pi over 4, this one equals pi over 4, and that one equals pi over 4. But I have to then label them correctly. So what I do is I start with this new period length, and I say pi over 4. And what we can do is simplify later, count up by ones for now. So we start here, this is currently technically a 1 pi over 4, right? Whenever there's no number written out in front of a variable or a term, it's a 1. So the next one would be 2 pi over 4, then 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, and 8 pi over 4. I counted past a full period just because I want to reiterate something. Like I went all the way of 2 full periods for this section, just to reiterate that you simply can count up the entire way. Is it really my most important thing that you can simplify down 4 pi over 4 to me? Not necessarily. Like if you left it like this, I would be okay with it. I'll take it. For the purposes of making sure that this is as accurate as it can be, 2 pi over 4 simplifies down 2 pi over 2. 4 pi over 4 simplifies down to pi. 6 pi over 4, 3 pi over 2, and 8 pi over 4 is 2 pi. Again, is it my most important thing that you simplify down those 3 lengths? Not at all. But the fact that you could get all of these just written out is super huge to me. Okay? So now again, we go with our cosine function, right? Cosine starts up. So we start up at that point. Then it comes to the axis, goes all the way down to the bottom, comes back up to the axis and back up to the top. And it might help if I used a different color on some of these. Oh, it's just turning out black anyways. Okay, there are those points. And let's just keep it going because I have more laid out here. I'm taking this of 2 full period lengths. So again, we started up, we go down, keep following this curve, and you can essentially just keep drawing this out, right? I know it's just going to keep going like this. If I had this drawn to scale, these would be like these tick marks would be even closer together because pi over 4 is super, super small. I'm not that concerned that you can draw these to scale. It's more about, are you getting your division lines correct? Are you getting the correct period length, the correct amplitude, and so on? Okay. Questions? Any questions at all? Do you guys feel like you can do this?
Don't know until I try it for sure.
Yeah. That's so true. Okay. Thank you, Jesse. Thank you, Tate, too. All right. I have full confidence in you guys. I'm going to go to that Google Doc really quick and grab the link for you. If you're super lazy, you can just go to the chat instead. And I'm posting the link in the chat. It's a longer assignment. So if you don't finish in this class period, I'm more than willing to let you finish this in part of the class period tomorrow and answer lots of questions over it. We have the time to be able to take the time this week and next week to really dive into this stuff hard. Like I want you to really understand graphing trig functions. I think some of my students last year left still a little bit confused because we didn't have as much time as you guys do right now. So I want to utilize this time. We're in a really good place this year, and I want to make sure that you all are understanding it. So we can take some time to finish this up. But you do have a couple minutes left if you want to get started on it. Otherwise, what you don't finish right now, let's finish in class tomorrow, because I'm anticipating quite a few questions over it. If you want to get started on it tonight, though, feel free to, so that you know what kind of questions you have to bring back. go ahead and get started. I think we only have about 3 minutes left though. So if you have any questions in the next 3 minutes, please ask them. If not, you are welcome to log off a little bit early and take a little drink break, go pet your dog, tell your cat I said hi, go smack your little brother if he's being annoying. You too, Wes. Have a good day. Feel free to stay on if you have any questions, but otherwise, you are free to go. But I will still be on here. Just chilling. Oh, if I could stop recording it now, though.